Hello everyone, welcome back to my channel Science Sutra. In this video, we will be seeing or we will be solving some problems, related to the sign convention for reflection by the spherical mirrors. The sign convention I have discussed in my last video, If you have not watched, please go and watch my last video related to the sign convention, okay? And in this before solving the problems, we need to follow some rules, let me go and do some recap for you. What I discussed in my last class. See, if I take all the signs we have to consider, right? See, if this is the pole, right? And here the center of curvature, and here will be the focus, right? We have to consider always the object to be the left side, and whatever the rays that is falling, it will fall on the concave mirror in this direction. So we have to consider the direction of incident light to be in this left side. This is left side for me, and this is right side for me, right? See, whatever the sign or whatever the measurements that we are doing towards the left, that we have to consider negative, and whatever the sign or whatever the measurements that we are doing towards the right, that we have to consider as positive, correct? So if I take, this is the object, right? So I will take this as AB, and in concave mirror you will generally get the image also in front of the mirror, right? But you will get a real as well as inverted image. So this will be the image. If I take, this is the image, this gives the distance. I have to measure the distance always towards the pole. This is V, and if I take, this is U, so in concave mirror, what I need to take? In concave mirror, U is always negative as well as V is also to be negative. And if I am talking about the height of the object, in this case it is positive, and height of the image, since we are getting the inverted image, we have to consider the height of the image to be negative. And if I am talking about the radius of curvature for concave mirror, how it will be? It will be negative. And even the focal length, if we want to measure the focal length, how we can measure? We have to measure the focal length from the principal focus towards the pole. That gives the focal length, and in this case the focal length is also taken to be negative. The signs which I am taking or which I am using here, this is very much important to solve the problems. This you have to go through, you had to memorize or you have to know how it will be, in the case of concave mirror. If I am talking about the convex mirror, how it will be, that I need to talk, right? I had discussed in the last video itself, but for recap I am doing, because I am doing the problems now, so it will be useful for you if you keep this in mind, This will be the pole in the case of convex mirror, correct? So, and this will be the center of curvature, and this is the focus, and the object is always taken to the left side. So the left side will be negative for me and right side will be positive for me, correct? So in convex mirror, what will be the case of U? U will be negative, correct? And what about the V? If we want to talk about the V, how the images that we will see in convex mirror, you will see always a virtual erect images, correct? So this is the image generally that you will get in a convex mirror. So V is positive in this case, and if I am talking about the height of the object is positive, and height of the image is also positive, since it is above the axis, right? You are getting the y points to be positive. If I am talking about the axis, this will be the y, positive y, and if you come down, it will be negative y. So height of the image is also positive, and what about the R value is also positive. Since you are getting the center of curvature towards the right side, so whatever the measurements that you are doing towards the right, you have to consider that as positive. And what else? F is also positive in the case of convex mirror. This conventions is very much important to solve the problems. So let's not waste much of the time. Okay, now let's move to the first question. What is the first question? You have to read properly. See, what is that? A convex mirror used for a rear view on an automobile has a radius of curvature 3 meter. If the bus is located at 5 meter from this mirror, find the position, nature and size of the image. See what kind of mirror they have given. If you see this, it is a convex mirror. They are talking about convex mirror. So in convex mirror, what all will be positive and what all will be negative? See, as you know, U is negative, correct? And V is positive and R is also positive. Height of the object is positive and height of the image is positive, correct? And what about the focal length is also positive, right? These things you have to keep in mind. Okay, the signs should be correct before solving. Okay, see, in a convex mirror, they are talking about the convex mirror. So what they have given, you have to write down here. Given radius of curvature they have given, correct? So in this case the radius of curvature is positive, so I have to take the positive sign. 3 meter, they have given R to be 3 meter. If a bus is located at 5 meter from this mirror, bus in the case here object, they have taken the object to be bus. Okay, so you can write here object as bus. So what is the distance they have given? They have given 5 meter from the mirror. Since you are taking U to be negative, why you are taking U to be negative? You are taking the U always towards the left side. If you measure the distance of the object from the mirror, you will get the negative sign. So U is equal to minus 5 meter, right? And find the position, nature and size of the image. Size in the sense you have to measure HI, okay? V you have to measure, and what else? Nature, how it will be, you have to know, okay, by solving this. See, you know that what you know. So R is equal to what you know, R is nothing but 2F. If you solve for F, how you will get? It is equal to R by 2. Since you know the value of R, easily you can find the value of F, right? So what is the value of R? It is 3 by 2. It is equal to, you have to write with the sign. Sign is very much important, okay? So it is equal to plus 1.5 meter. So now you got to know the value of F, right? Now you know the value of F and you know the value of U. What you can find? As you know, mirror formula. From mirror formula, what you know? 1 by F is equal to 1 by U plus 1 by V, correct? So 1 by F, what is the value of F here? It is 1 by 1.5 plus with a positive sign. What about V here? If you see the value of V, what is the value of V? They have given the value of V U as minus 1 by 5 plus 1 by V, right? So we have to solve for V, 1 by V. If you move this towards left side, what will be? 1 by 1.5 plus 1 by 5. Is it correct? So if you take the LCM, what is the LCM? You will get 1.55 5. Okay. If you multiply 1.5 with 5, how much you will get? 7.5. So you will get around 7.5. So what is the value? 1 by 1.5 into 7.5. It is almost 5 plus 1.5. So it is equal to how much? 5 plus 1.5. 5.0, 1.5, 6.5. So you are getting 6.5 by 7.5. So you will get the value of V. Since this is in terms of 1 by V is equal to 6.5 by 7.5. Since we want the value in terms of V, how we can do? You have to take the reciprocal. So it will be 7.5 by 6.5. Okay. So this is the value of V with a positive sign. You are getting with a positive sign. Okay. So if you are getting a positive sign, what that mean? The image is formed behind the mirror, correct? The image is formed behind the mirror. At a distance of 7.5 by 6.5 meter. Unit is also very much important. Okay. So image is formed behind the mirror at a distance of this much. You don't know, right? You know the magnification formula, right? Magnification, how you can write? It is equal to h prime by h, and it is also equal to minus v by u. You know the value of v and you know the value of u. You need to find the value of m here. What is m here? M is equal to minus v by u. See, if you take the values of v, what is the value of v? It is 7.5 by 6.5 into. Since you are having u in the denominator, so I will multiply with u value. That is equal to minus 5 meter. Correct? So, since it is minus into minus, you will get plus. So, it is 7.5 by 6.5 into 5. So, what is the value here if you solve? So, if you solve, how you will get the answer? Say 5 ones are 5 ones are 5 5s are 25. Correct? So, since the points here decimals is in same place, you can take off that it will be equal to 15 by 65. Okay. So 15 by 65, if you solve, it will go which table? Fifth table, right? So 5 3s are 15, 5 1s are 5 5s are. Sorry, 5 1s are 5 3s are 15. So if you solve 3 by 13, okay, 13 3.0, 13 2s are 26. Correct. 4 0, 13 3s are 39. So like this it will go. Okay. So the m value finally how much you will get? You will get plus 0.23. So this is the answer. Okay. And finally what you will get? What you can conclude from the value of m, since you are getting the m to be positive. What the positive represents? The positive represents the image is said to be virtual. Okay, so you can write here, since the magnification formula, since the magnification is positive, the image is positive, the image is said to be what? It is said to be virtual. Okay. From the sign of M, you will get to know whether the image is real or virtual. Since you are getting the image to be positive, you will say the image is called to be virtual. Okay. This is how you can solve the problem. Okay. Next, what's the next problem? If you see this is the next problem. What is that? If you read out, an object 4 centimeter in size, that means they have given the object h as 4 centimeter, but we don't know whether it is positive or negative. Okay, is placed at 25 centimeter in front of a concave mirror. They are talking about what? They are talking about concave mirror. So what all should come to your mind then? You had to take U to be negative. Then what about V? V is also negative. Right? Height of the object is positive. Right? Height of the image is negative. R is negative. F is also negative. These signs you should know before solving the problem. So since they are given the object size, so I have to take with a positive sign, that is 4 centimeter. And they have placed how much of distance? They have placed at 25 centimeter in front of a concave mirror of focal length. What they have given focal length? You have to take with negative sign, 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and the size of the image. They are asking to find the nature. Size means you have to find hi. Okay. And what else you need to find? You need to find the nature of the image. Okay. From these values, okay, what you can find? From what distance from the mirror should a screen be placed in order to obtain a sharp image? That means you need to find V value. What is the V value you need to find? Yes. How you can find the value of V? You know the mirror formula, right? So you need to write here from mirror formula. Okay. What is the mirror formula? 1 by F is equal to 1 by U plus 1 by V. Correct? So you know the value of F, you know the value of U, but you don't know the value of V, right? So I need to solve for V. 1 by V is equal to 1 by F minus 1 by U. So 1 by V is equal to, what is the value of F? Since it is negative, you have to take with negative sign, minus 1 by 15, and U is also negative. Here negative will be positive, so plus 1 by 25. So what is the LCM? If you take, it will be 75, I think. 15, 25. What is the common multiple? Common factor? 5 3 is 5 5 is 5 3 1. So 5 5 is 25, 25 3 is yes, it is 75. So 15, if you take minus 1 by 15 into 75, so it will be 15 2 is 15 3 is 45, 15 4 is 60, 15 5 is 75, right? So it is, yes, 15 5 is 75 minus 5 plus 1 by 25 into 75, it is 3 times. So it will be minus 2 by 75. So if I want to solve for V, how can I solve for V? So V is equal to minus 75 by 2. It is equal to minus 3 times, okay, 3 2 sevens are 14.5 centimeters. So from this, what you can conclude? You have to place the screen at a distance of 37.5 centimeter, okay, 37.5 centimeter distance you have to place in order to get the image. So finally you have to conclude like this. The screen should be placed at a distance of 37.5 centimeter to get the image. Okay, this negative sign shows it is towards the left side, so you are getting the negative side. Next, what you need to find? You need to find the nature as well as the size of the image. Size, how you can find? By knowing the magnification formula, right? So m is equal to h prime by h. Okay, so you know the value of h, I think. Do you know the value of h? Yes, you know the value of h, and you don't know the value of h prime. Is it correct? You don't know the value of h prime. So you have to equate with one more formula, that is minus v by u. If you solve for h prime, minus v by u into h. Correct? So what is the value of v here? That minus 37.5. Since you are having minus with the minus sign, so it will be positive. 37.5 divided by, what is the value of u? U is negative. Again you will get the negative sign. So it is 25 centimeter into 4, I think. Is it correct? 4. Yes, with a positive sign. So if you solve, what will be the value? Minus 6.0 centimeters you will get. Since you are getting with a negative sign, what does it mean? The image is inverted, right? Only if you are getting the inverted image, then only you will get the h prime to be negative, right? The image is inverted and enlarged. Since we are talking about the concave mirror, we have to consider the image to be enlarged. So the image is inverted and enlarged. Why I am taking enlarged? If you compare h prime with h value is 4 and h prime is 6. So the image is said to be enlarged. This is how you can conclude the nature as well as the size of the image. Okay, and this is how you need to solve the problem. Okay, if you know the sign conventions properly, then only you can solve easily. Understood, children? Okay, next. Yes, this is the question which they have given in your book. Okay, find the focal length of a convex mirror whose radius of curvature is 32 centimeter. Yes, here what they have given? They have given the radius of curvature as 32 centimeters, right? Since we are talking for a convex mirror, we have to take that with a positive sign, correct? We have to find the focal length. Okay, you know that r is related to f like this, right? R is equal to 2f. If you solve for f, it will be equal to r by 2. So it will be plus 32 divided by 2. How much you will get? You will get around 1 time 2 6, right? So you will get around 16 centimeter with a positive sign. This is how you can find the focal length for a convex mirror. And one more question what they have given. A concave mirror produces 3 times magnified real image. What is the magnification value they have given? Concave mirror, since it is a real image, okay, and enlarged, what will, yeah, in this problem if you see a concave mirror they have given, okay, a concave mirror produces 3 times magnified real image. See, while I'm explaining about the magnification, I told you that when m is negative, you have to consider that, okay, as a real image. So m should be taken negative, okay, minus, and what will be the value here? 3 times magnified. That means the value of m you have to take as 3. And since you are talking about a concave mirror, what about the object distance? You had to take with a negative sign, that is minus 10 centimeter in front of it. Where is the image located? You had to determine what is v value. Okay, so what is the formula? If you see, m is equal to minus v by u, right? Since you know the value of m as minus 3 is equal to minus of what? Minus of v divided by u, correct? Since we don't know the value of v, we need to solve for, okay, this minus get cancelled, so v is equal to 3 into u, correct? So v is equal to 3 into, what is the value of u here, is minus 10, so v is equal to minus 30 centimeter. This is how you can determine the value of v from the magnification formula. Okay, I hope you have understood these problems. Okay, please, if you have any doubts regarding, you can please comment in the comment section. You can give the comments in the comment section so that I can answer to your questions. Thank you. If you like this video, please subscribe to my channel Science Sutra, and please share to your friends also, so that it will be helpful for them also. Thank you. If you like it, please subscribe to my channel. Thank you.